Good morning, everyone. Today we are going to see the topic unit quantities. In order to predict the behavior of a turbine working under a various condition of head, speed, output, gate opening, the result are expressed in terms of quantities which may be obtained when the head on the turbine is reduced to the unity. The conditions of the turbine under which head are such that the efficiency of turbine remains unaffected. The following are the three important unit quantities which must be studied under unit head, and that quantities are unit speed, unit discharge and unit power. Then first we are going to see about unit speed. Then what is unit speed? What is unit speed? Unit speed is defined as speed of the turbine working under a unit head, that is head of 1 meter, and it is denoted by the term NU. The expression for the unit speed is obtained as below. Capital N is equal to the speed of the turbine under a head, capital H. Then capital H is equal to head under which a turbine is working. Then small u is equal to tangential velocity. As we are know, the tangential velocity, absolute velocity of water and the head on the turbine are related as below. U is proportional to V, where V is proportional to square root of H. Therefore, U is proportional to square root of H. Now, the equation U is equal to pi dn divided by 60. Where capital D, that is diameter of turbine, is constant. Therefore, U is proportional to capital N. U is proportional to capital N, or we can write it as N is proportional to U. N is proportional to U, or we can write it as speed is proportional to square root of H. Square root of H. Now, N is equal to K1 into square root of H, where K1 is the constant of proportionality. K1 is the constant of proportionality. If the head on the turbine becomes unity, the speed becomes unit speed, or we can write it as when H is equal to 1, at that time N is equal to NU. N is equal to NU. Substituting these values in the above equation, that equation is equal to, and that equation is N is equal to K1 into square root of H. Therefore, NU is equal to K1 into square root of 1.0, that is equal to K1. Therefore, K1 is equal to NU. Now we can write it as N is equal to NU into square root of H, or we can write it as unit speed is equal to speed divided by square root of h. Unit speed is equal to speed divided by square root of head. Okay, this is the equation for unit speed. Now we are going to see the equation for the unit discharge, and it is denoted by QU. Unit discharge is defined as discharge passing through a turbine which is working under a unit head. It is denoted by symbol QU. Now second derivation is unit discharge, that is QU. Capital H is equal to head of water on the turbine. Capital Q is equal to discharge passing through the turbine when head is capital H on the turbine. Small a is equal to area of flow of water. Now, as we know, discharge Q is equal to area of flow into velocity. Area of flow into velocity. But for a turbine, area of flow is constant and velocity is proportional to square root of h. Q is proportional to velocity Q is equal to K2 into square root of h. Now, unit discharge. H is equal to 1. Therefore, Q will be equal to QU. Okay. Then substituting these values in the above equation, in this equation, we will get QU is equal to K2 into square root of 1, that is equal to K2. Substituting the value of K2 in this equation, we will get equation as Q is equal to QU into square root of H. Therefore, QU is equal to Q divided by square root of H, and this is our final derivation for the. Here we will end our lecture.